Hi everyone, welcome to Go Classes. In this lecture, we will solve context-free grammar's gate previous year questions. We are going to solve each and every gate previous year question from the topic context-free grammar and regular grammar. Okay. Let's solve gate 1995 question. Which of the following definitions below generate the same language L? So this language L is given to us and the question is asking which of these will generate the language L. Now this is a very simple question. If you notice the language L, this is x power n, y power n is greater than equal to 1. This is non-regular, yes or no? The language L, that is x power n, y power n, where n is greater than equal to 1. This language is what? This language is non-regular, yes or no? Okay, this is a standard non-regular language. So because this is a non-regular language, so can regular expression generate non-regular language? Notice here the option 2 comma 3, these are regular expressions. What are these are regular expressions. Can they generate non-regular language? The answer is no. If you have a regular expression, if you have a regular expression R, then remember the language will always be regular. Okay, so very easily I can say that this language L, this is non-regular. So this option 2 comma 3, these are regular expressions and they can never generate non-regular language. So definitely 2 comma 3, these are not the answer. Okay, we want that from these three, 1 2 3, from these what will generate the language L? Language L is non-regular. So these regular expressions 2 comma 3, these are regular expressions, they will generate regular language, so they are not the answer. So the automatically which option is remaining? Only option A is remaining. And this is actually very simple. Look at option A. In the option A we have the grammar, that is E going to, you can see this is the grammar. I can replace E with xey, or I can replace E with xy. Now from this grammar we can easily see that it will generate which language? The language will be x power n, y power n, where n is greater than equal to 1. Because in this grammar you can see that for every x there is a y. Okay, if you look at this grammar, then we can generate xy, this string xy we can generate. Okay, this is the start variable, this start variable I can replace with xy, so this xy string I can generate. Okay, you can notice that this E I can replace with xey, and now this E I can replace with xy. So what I will get? This E I can replace with xy, so I got x power 2, y power 2. Okay, like this if you notice that from this E what will happen? It will happen that there is, okay, if I replace this E with xey, okay, there is a, for every x there is a y. Now there is E here, yes or no? So now what I can do, this E I can replace with xey. Okay, this E I can replace with xey. So again I got this. Now this E I can replace with xey. Okay, so the idea is very simple, that basically we are getting x power 3, y power 3. For every x we are getting y, yes or no? So basically I can say that you are getting x power n, e, y power n. Okay, and then remember at the end this E I can replace with xy. Okay, at the end this E I can replace with xy. So finally what I can generate? I can generate string xy, I can generate string x square, y square, x cube, y cube. Okay, so like this. So finally I can say the language will be x power n, y power n is greater than equal to 1. Okay, so very simple that this grammar it will generate the language L which is given to you in the question. So answer will be option A. What are the counter examples for 2 comma 3? Can anyone tell me? We have already seen that this will definitely generate the language, so this is definitely the answer. But you tell me the counter example for option 2 comma 3. Like you can easily see this 2, look at 2, I can generate xy, this string I can generate, yes or no? Also it is given that x plus xy, y plus. Okay, see here we have any number of x, yes or no? And here we have any number of y, at least one x, at least one y. So from here if you look at the language, which strings I can generate? I can generate string xy. Okay, now this x plus, what it means? It means that you can repeat x any number of times but at least one x. Okay, this means basically you can repeat x greater than equal to one time. Okay, and similarly this y plus, what it means? It means you can repeat this y greater than equal to one time. Okay, so very simple. Here you can see if I repeat this one time, if I repeat this one time, then I will get x square, y square. But remember, there is no connection between these two, this x plus and this y plus. they have nothing to do with each other. So I can say that you can repeat this any number of time, you can repeat this any number of time. For example, I can repeat this 2 time. Okay, if I repeat this 2 time, then including this I will get x power 3. Okay, I will get x power 3, and if I repeat this, let's assume 6 times, then I will get y power 7. So this type of strings are also possible. Okay, in this I can say here which strings are possible. For example, you can easily see that x power 3 y power 7, that this is also possible, this is also generated. But you can notice this string is not in this language. This language does not contain, there is no string x power 3 y power 7, this type of string is not there. So this is the counter example for option 2. What about option 3? In option 3 you can notice the language will be like this: x power n y power m, where both n comma m are greater than equal to 1. Okay, because we have x plus y plus, so the language will be x power n y power m, where n comma m these are greater than equal to 1. So remember, here what you can generate, in this you can generate, for example, x y power 2, you can generate x power 2 y, of course you can generate x power 2 y power 2 also, you can generate x y also, and so on. Okay, so you can see these are the counter examples, because we can generate x y power 2. Okay, so that is the reason I can say these are the counter examples, and your answer will be option A. So this is a very simple question. Non-regular language is given to you, and these are regular expressions, so they cannot be answer. They can never be the answer for a non-regular language. If you have a non-regular language, then for this non-regular language, we can never write. We can never write regular expression. For this non-regular language, there is no regular expression that exists. Okay, there is no regular expression which can describe non-regular language. Let's all get 2023 question. Consider the context-free grammar that is given to you. S, X are non-terminals, A, B are terminal symbols. The starting non-terminal symbol is S. Which of the following statement is correct? The question is asking what the language that is generated. Okay, and the question is asking, is the language that is generated that is regular? Okay, so the question is asking for the language that is generated from this grammar. So let's see what is this grammar. So in this grammar we have x, this start variable s. Okay, I can replace it with asb, or I can replace it with x, and this x, this is ax or xb or a comma b. Okay, so let's see what the language that is generated from this grammar. Now you can easily see this is actually the standard grammar for, this is the standard grammar for a star b star. Okay, so remember this will give you a star b star, but remember here you have a comma b, at least one of them you must generate. So let me tell you, for example, okay, actually if this is, let's assume if this is epsilon, okay, then in this situation the language, what x will generate, x will generate a star b star. Okay, this is what I'm saying, that if you have this situation that x is going to ax xb epsilon, then what we can generate, we can generate a star b star, because you can easily see that here after b a cannot come. Okay, here what you can see, for example, I can generate empty string, I can generate a, I can generate a square, I can generate a cube, and so on. I can generate b also, b square also, and so on. You can easily see I can generate ab. Okay, what we can do, we can generate a square b square also, a square b also. Okay, so but you can notice that after b a cannot come. Okay, whatever you do, because here we have x b and here we have ax. So remember, it will be like this, that this x, when I replace this x with ax, then remember a will be in the starting and then there will be x. Now you notice, if I replace this x with ax, then what will happen? Then again what will happen? Then first a will come, then x will come. Now notice, if I replace this x with xb, if I replace this x with xb, okay, now you notice that this b is coming at the end. So after a, b is coming. Yes or no? Now you can notice, if I replace this x, let's assume this x I replace again with xb, then what will happen? Then you can notice first x will come, then b will come. Please notice that first x is coming, then b is coming. Okay, now if I replace this x with xb, then again first x is coming, then b is coming. Okay, and if I replace this x with ax, this x if I replace with ax, then what will happen? Okay, if I replace this x I'm replacing with ax, then first a will come, then x will come. Okay, so I hope you are getting the idea that we cannot have a after b. Yes or no? After b a cannot come. I hope you understood this. So remember, in this x going to ax or xb epsilon. Here you can see which strings I can generate. This is a standard grammar for a star b star. This is a standard grammar because here you can see after b a cannot come. A cannot come. Okay, so that is the reason you can easily see, you can generate some strings and you can check. Okay, because you can see after x b will come. If you replace x with xb, then after x b will come, and if you replace x with ax, then first a will come, then x will come. So here whatever you do, the language will be a star b star. This is the standard grammar for a star b star. Okay, now come back to this question. Here you can notice we don't have epsilon, so at least one a or at least one b we should generate. So what will be the language here? Tell me. If I remove this part, okay, then tell me what will be generated by x here. You can easily see again after b a cannot come. Okay, so but remember at least one a or at least one b we must have. So it will be like this. It will be, the answer will be here, you must have a power m b power n. Okay, where either m is greater than equal to 1, either m is greater than equal to 1 or n is greater than equal to 1. Okay, this will be the language. Is this point clear? The language will be a power m b power n, where either you must have at least one a or you must have at least one b. So you can see either m will be greater than equal to 1 or n will be greater than equal to 1. Okay, clear? Let me know. Because in this you can see which strings I can generate. I can generate, for example, string a. I can generate string b. I can generate string power a power 2, a power 3. Okay, you can also generate, for example, you can generate a power 2 then b. Okay, so many strings you can generate, and you can see the language will be a power m b power n, where either you must have at least one a or you must have at least one b. So either m is greater than equal to 1 or n is greater than equal to 1. So this is what x will generate. Very simple point. Okay, now once you have found what x is generating, then tell me what s will generate. Let me know. From here you tell me what s will generate. Okay, so you just forget about x because we already know what x will generate. Okay, so now tell me what s will generate here. So you can see this s, either I can replace this s with x, or this s I can replace with asb. Here basically for every a there is b. Now this is a standard production which will generate a power n b power n. Yes or no? So you can easily see from here s. Okay, I can replace this s with asb. Now you notice this s, if I replace again with asb, already there is a, already there is b. Now this s, if I replace with asb, I will get like this. So you can notice I got 2a 2b. Okay, similarly remember, if I replace this s with again asb, then already I have double a, there is double a, already there is double b. And if I replace this s with asb, then you will get a power 3 b power 3. Okay, so basically what I am saying that this s going to asb, if you look at this rule, what this rule will generate, this rule will generate a power n s b power n. Okay, is this clear? Or I can say, yeah, so this is the correct idea. So this is what it will generate. And remember, finally this s I can replace with x. Finally this s I can replace with x. So finally I can say that it will generate a power n x x b power n. And remember, we can directly generate x. Of course we can directly generate x. Okay, so because we can directly generate x, finally I can say that this s is generating a power n x b power n, where n is greater than equal to 0. Okay, is this clear? This is what s will generate. Understood? So finally I can say what s is generating, because that will be your language. From the start variable what you can generate, that will be your language. So we have already seen that this s is generating a power n b power n. In middle there is x. Okay, in middle there is x, where n is greater than equal to 0. And remember what x is generating, that we have already seen. What x was generating, this was generating at least one a or at least one b. This was basically generating, I can say, a power p b power q. Okay, where a power p b power q, where either p is greater than equal to 1 or q is greater than equal to 1. Correct? Is this clear? Okay, why I am writing p comma q? Tell me why I am writing p comma q, why I am not writing m comma n? Because if I write m comma n, then you will confuse that, okay, this n, and if I write n here, then you will confuse. But remember, this n, this power has nothing to do with this power. Do you agree? Very simple point I am saying. If you write m comma n, for example, like this, then you will confuse that okay, this is b power n, so this is also power n. Then you will be thinking okay, this is same as this, but actually these powers have nothing to do with each other. Yes or no? Because this x is separate. What this x will generate, this will generate a power p, b power q, any number of a followed by any number of b, but here at least one a or at least one b should be there. And what this s will generate, this will generate any number of a, x, any number of b, sorry, equal number of a, equal number of b, basically a power n x, b power n, where n is greater than equal to 0. So now if you replace this x with this one, then what you will get, the language will be a power n, this x I can replace with a power p, a power p, okay, b power q, then b power n, where remember n is greater than equal to 0, okay, and also p is greater than equal to 1 or q is greater than equal to 1, correct? Okay, so this is the idea. So tell me finally what is the answer, what language you will get. Here we have seen the language that we are getting, that is a power n, then a power p, then b power q, and then b power n, where n is greater than equal to 0. Okay, but you can notice p comma q, p comma q, they are at least one of them is greater than equal to 1. Either p is greater than equal to 1 or q is greater than equal to 1. Okay, so if you notice here, because of this a power p, because of this b power q, actually you can generate anything. Okay, finally actually it will become, because remember n is greater than equal to 0. So what you can do, you can just put 0 0 here. Okay, if you put 0 0 here, because n is greater than equal to 0, if you put n equal to 0, then what you will get, then you will get basically a power p, b power q. Okay, is this clear? Or you can think like this, this I can write a power n plus p, correct? And this I can write b power q plus n, b power q plus n. And remember n is already greater than equal to 0. Also it is given that either p is greater than equal to 1 or q is greater than equal to 1. Okay, so this is your language. Now you can easily see, if p is greater than equal to 1, then tell me, if p is greater than equal to 1, then what can you say about n plus p? Where n is already greater than equal to 0. If p is greater than equal to 1, n is greater than equal to 0, then what you can say about p plus n? This will be greater than equal to 1. Yes or no? If p is greater than equal to 1, n is greater than equal to 0, then p plus n, that will be greater than equal to 1. And similarly, you can see that if q is greater than equal to 1, okay, if q is greater than equal to 1, n is greater than equal to 0, then what it will become? Then what I can say? I can say q plus n, that will be greater than equal to 1. Okay, so finally you can easily see that your language actually will be what? Your language, I can simply write that, okay, a power p, b power q, where where either p is greater than equal to 1 or q is greater than equal to 1. I hope you understood this. Okay, because basically this will mix, and either this will be greater than equal to 1 or this will be greater than equal to 1. Okay, is this clear? Please tell me, because you can easily see, if p is greater than equal to 1, n is greater than equal to 0, then what will be p plus n? That will be greater than equal to 1. If q is greater than equal to 1, n is greater than equal to 0, then q plus n will be greater than equal to 1. So finally, if you notice, the language will be this. Okay, and tell me, is this language regular? The final language that we are getting, that is like this: a power m, b power n, where either m is greater than equal to 1 or n is greater than equal to 1. This is the final language you am getting. Is this language regular? Yes, of course, this language is regular. Yes or no? Because here, what will be the regular expression? Tell me, this language is regular. Why? What is the reason? Because you can write the regular expression. The regular expression will be like this: either I must have at least one A, B can be anything, union, A can be anything, and I must have at least one B. So I can write this regular expression. Because regular expression exists, so the language will be what? The language will be regular. Okay, is this point clear? So here you can see the answer will be a plus b star or a star b plus. So here, for this question, which statement is correct? Remember, the language is regular, so option D is wrong, because the language I am getting, that is regular language I am getting. Okay, so here you can see the answer will not be option C. What is the reason? Option C is not the answer. What is the reason? Because in the option C, you can see that I can generate this type of string A, B, A. But this string is the counter example. From here, I cannot generate A, B, A. Okay, from here, I cannot generate A, B, A. So this option C is gone. Okay, option A is also gone. Because from option A, what I can do? From option A, I can generate A, B, A. but here I cannot generate ABA. So which option is correct? You can see option B is correct. What option B is saying? Look at option B. What option B is saying? Option B is saying basically that A star, either A or B should be there, then B star. Okay, so if you see this option B, if you open it, what you will get? You will get A star. Basically, if you open it, for example, this will become A plus, either A plus B star, or or A star B plus, or A star B plus. Okay, so your answer will be option B. Is this point clear? Please tell me. Let me know. So this is a very simple question. You can just see what this X will generate, what this S will generate. Okay, and then you can easily find the language. Okay, for this grammar, the language that will be A plus B star or A star B plus. This will be the language. And because this is the language, so in simple words, you can basically write that, okay, A star, either A or B should come, then B star. Okay, so this is how I can write. And that is your option B. I hope you understood. Now let me tell you one thing. Here, can you notice this given grammar? Look at this given grammar and tell me, is this regular grammar or not? The grammar that is given to you, is this regular grammar? You can easily see that this grammar is not regular grammar. Yes or no? Because in this production, we have on the right side, we have one variable, but that variable is not on the rightmost position or on the leftmost position. Okay, you can easily see this is not a regular grammar. For example, because of these two also, this is not a regular grammar. You can easily see that this is the violation of left linear grammar, left linear grammar, and this is the violation of right linear grammar. Also, you can see this. You can see this. This is the violation of left linear, right linear, both. Okay, so you can see this violation of left linear grammar, also right linear grammar. So because this grammar is not left linear, also this is not right linear grammar, so this grammar is not regular grammar. Okay, now tell me, if this is not regular grammar, can it generate regular language? Is it possible it can generate regular language? Tell me. This grammar, this is not regular grammar. Remember, this given grammar, this is not regular grammar. So tell me, if this is not regular grammar, can it generate regular language? Can a non-regular grammar generate non-regular can a non-regular grammar generate regular language? The answer is yes, it is possible. Yes or no? Okay, we have already seen in our lectures. See these two questions. Tell me the answer for these two questions. A regular grammar necessarily generates regular language. This statement is definitely true. If your grammar is regular, then your language will be definitely regular language. But what about non-regular grammar? If your grammar is not regular, then can I say your language will be non-regular? This statement is false. Okay, this statement is false. Very easily I can give you a non-regular grammar. Okay, consider this grammar G, where S is going to SS or A. Here you can easily see this grammar is a non-regular. Yes or no? This grammar, you can notice this is a non-regular grammar. Okay. Now, what is the language here? So remember, G is non-regular, but what is the LG? If I ask you what is LG, you can easily see that is A plus. So this is regular. Yes or no? The language is regular. I hope you understood. So remember, if you have a non-regular grammar, then the language may or may not be regular. Okay, I can give you another example where I will give you non-regular grammar and the language will be non-regular. Okay, for example, you can consider this grammar. S is going to ASB epsilon. Now, this grammar is also non-regular. Okay, if you look at this grammar, this is also non-regular grammar. Okay, and here what will happen? Here, if you find the language, that will be non-regular. Here the language, that is basically A power n, B power n. A power n, B power n, where n is greater than equal to 0. And this language is non-regular. Okay, this language, this is a non-regular. So this is what I'm saying that. This is what I'm saying that if you have a regular grammar, remember, if you have a regular grammar, if your grammar is regular, then definitely language will be regular. Okay, but remember, if you have a non-regular grammar, if you have a non-regular grammar, then remember the language, either it can be regular language or it can be non-regular language. Is this clear? Okay, very simple. You can see. that this is a non-regular grammar. If you think about it, okay, here you can easily see this is not right linear because of this production, and because of this production this is not left linear, correct? Okay, so if you look at this grammar is, this is not left linear grammar, okay, because of this production, and this is not, okay, if you see, this is not a regular grammar. So this is not a regular grammar. But if you notice, if you find the language for this grammar, let's call it grammar G. Okay, so if you find the language for this grammar LG, then let me tell you what will be LG, because here you can notice this C will generate C star, what X will generate, it will generate B or C star, and what S will generate, this will generate A followed by X, and what X can generate B or C star. Okay, so if you see that the language is AB or AC star, which is a regular expression, which is a regular expression, so the language is basically regular. Okay, so the language is a regular language. Okay, is this clear? So you can notice the grammar is not regular, the grammar is not regular, but the language is regular. So finally what I want to say, I want to say if you have a regular grammar, the language will always be regular. Okay, but if you have non-regular grammar, then language may be regular, language may not be regular. Okay, is this point clear? So this is the point. So remember, this is a note that a regular grammar will always generate regular language, but non-regular grammar may or may not generate regular language. Okay, is this clear? So remember, in this question the given grammar is actually non-regular. Okay, but the language that it is generating, that is actually regular. Okay, is this clear? Many students they think that, okay, if the grammar is non-regular, then the language will not be regular, but that is not correct. If your grammar is non-regular, then language may or may not be regular. Okay, but if your grammar is regular, then your language will always be regular. For this question, the question is asking what is the language, so you have to find the language, and if you find the language you can easily see that answer will be option B. Okay, and let me tell you one more thing. Okay, see, if you find the language will be regular, and the remaining options you can easily eliminate, because from this grammar if you check, we cannot generate ABA. Okay, from this grammar we can never generate ABA. Okay, but you can see option A comma option C, they can generate ABA. So these options you can eliminate very easily. Anyway, the answer will be option B. This is actually very good question. Okay, let's solve GATE 2017 question. Identify the language generated by the following grammar. S is the start variable. A grammar is given to us. What are the language? So this question you can solve by many different methods. Okay, but let me tell you, if you look at the options, then all the options are telling you a power m, b power n, a power m, b power n. The only difference in the options, that is what is the range of m comma n. Okay, yes or no? So let me tell you the best way to solve this question in the GATE exam, that is take some strings and you eliminate the options, because if you look at the options, then all the options are saying a power m, b power n, a power m, b power n. So that is clear that the language will be a power m, b power n, and the options are saying m is greater than equal to n or m is greater than n. Okay, the value is n is greater than 0 or n is greater than equal to 0. So you can see this is the only difference in the options. Okay, so what you can do, you can eliminate the options very easily. Okay, here you tell me which options can I eliminate and which options can I not eliminate. See, from this grammar which strings can I generate? Can you tell me? Give me some strings which can be generated, some small strings, generated strings. What are the minimum size string that I can generate? You can see s is going to xy, and from x the minimum I can generate, that is a. Okay, and from y I can generate epsilon. So remember, string a is generated, string a that is generated. Okay, so tell me which option is gone. String a is generated, so tell me which option is gone, let me know. You can easily see, because string a is generated, so n greater than 0, this option is gone, because n is greater than 0. N greater than 0, this option is gone because of this string. Okay, do you agree? Similarly, this option is gone, option a is also gone. Okay, because in the option a we have n greater than 0. Okay, in the option D also we have n greater than 0. But okay, so you can see that option A comma D are gone because of this single string A. Okay, tell me which other string you can generate. You can generate C. From X I can generate A. From X I can generate A. From Y I can generate, for example, AB. Okay, yes or no? So I can generate double AB. What else I can generate? What else? You can notice. I can generate, for example, triple AB also I can generate. Okay, so I can generate from X I can generate A, and then I can generate here. From here I can generate A power 2 B power 2. Okay, A power 2 B power 2. So like this, these strings I can generate. Remember, from X I can generate A square also. Okay, and then from there I can generate AB also. I can also generate A square. Okay, from X I can generate A square, and from here I can generate epsilon. So basically these strings are generated. Now you can easily see which option is gone now. Tell me. So look at option C. Option C is saying that M is greater than N. Okay, this is what option C is saying, that M is greater than N. Then tell me one thing. Is it possible in all these strings, look at all these strings, is it possible that I can generate number of A equal to number of B? It is not possible. Okay, actually the answer will be option C, because you can easily see what this option B is saying. Okay, look at this option B. From option B, which strings can I generate? Tell me. From option B, you can see A power M, B power N, where M is greater than equal to N and N is greater than equal to 0. So from option B, actually empty strings should be generated. Option B, if you look at option B, this option B can generate empty string also. Yes or no? But empty string is not generated from the given grammar. So that is the reason option B is also gone. Is this clear? Because option B can generate empty string. You can notice what option B can generate. Because in the option B, I have A power M, B power N, where M is greater than equal to N, N is greater than 0. So actually, from this option, you can see that I can generate AB also. But from the given grammar, I cannot generate AB. Okay, yes or no? From here, I cannot generate AB. I cannot generate epsilon. So option B is gone. And finally, your answer will be option C. Did you understand? So this is the method number one. You can eliminate the options, because in this question, if you look at the options, all the options are saying A power M, B power N. Okay, and the only difference is here. So what you can do, you can take some small strings and you can eliminate the options. You can easily see that this will generate A, this will generate A square B. This type of strings will be generated. Okay, but you can easily see that this will not generate. What it will not generate from the given grammar? What it will not generate? It will not generate empty string, it will not generate AB. This type of strings will not be generated. Now from these counter examples, you can eliminate option B. Okay, for option B, the counter example, what will be the counter example? The counter example will be epsilon, the counter example will be AB. These are the counter examples for option B. Option D is also gone, because option D counter example will be A. Okay, the counter example will be A. Similarly, option A, the counter example is A. So these options are easily gone, and finally your answer will be option C. Now let's do the complete analysis of this grammar, what this grammar can generate. So let's see. The grammar that is given to you, that is S, I can replace with XY. X can go to XY. And what X can generate? X is going to AX or A, and Y is going to AYB or epsilon. Okay, this is what is given to you. Now you can easily see, tell me, this X, this does not depend on any other variable. Yes or no? This is X going to AX or A. So X is not depending on any other variable. What X can generate? Tell me. From here, what I can say? What will X give you? X will give you A plus. Okay, yes or no? You can easily see X will give you A, X can give you double A, X can give you triple A, and so on. Okay, so very simple. X will give you A plus. What Y will give you? Let me know. From Y, what can you get? You can see this Y, this is the standard grammar for A power n, B power n, because you can see for every A you are getting a B. If this Y I replace with AYB, then again what you will get? You will get A power 2, Y, B power 2. Finally, this Y you can replace with A, with epsilon. So what you will get? Remember this Y is giving you A power n, B power n, where n is greater than equal to 0. Okay. So tell me what X will give you. What S will give you? What S will give you? Because what S will generate, this is the start variable. What it will generate, that is your language. So what S will give you? Let me know. S will give you X. X is already A plus. Y. What is Y? y is a power n b power n where n is greater than equal to 0. So tell me, what is the language finally? The final language that will be a plus a plus a power n b power n where n is greater than equal to 0. So here if you notice, because I have at least one extra a, yes or no? Remember, number of a equal to number of b. Okay, number of a equal to number of b, but remember here I have at least one extra a plus means at least one extra a. So what I can say? I can say that number of a will be actually greater than number of b. Yes or no? If I say a power m, b power n, because this is at least one a. Either it can be a or double a or triple a and so on. Because this is a plus. So you can see that, okay, this number of a, if you look at, that is at least I can say that is greater than number of b. So you can see this m is actually greater than number of b, and this n is greater than equal to 0. So this will be your language. I hope you understood. This is the complete analysis. Now you can easily see your answer will be what? A power m, b power n, where m is greater than n. Number of a is greater than number of b, and number of b is greater than equal to 0. So you can see your answer will be option C. Okay, number of a is greater than number of b, and number of b is greater than equal to 0. Okay, so very simple. Is this clear? Let me know. Now, one more thing. In the grammar, what changes can I do so that I can get grammar for option A, B, D? Let me know. So far, we have seen that for this given question, okay, for this given grammar, the answer will be option C. Okay, now you tell me, what changes can I do in the given grammar so that I will get answer option A? Let me know. See, option A, what option A is saying? Option A is saying A power m, B power n, where m is greater than equal to n. Okay, and n is greater than 0. Okay, this is what I want. So tell me, what will be the grammar for this? Let me know. What changes can I do? Here you can notice n should be greater than 0. So first of all, here you cannot generate. Okay, here at least AB you generate. Okay, is this clear? Here at least AB you generate. This change you do. Okay, let me explain. Basically, if you want the grammar for this, let's do the analysis. A power m, b power n, and I want the grammar for m greater than equal to n, and n is greater than 0. Okay, this is the language. Okay, now you notice this is the option A. Let me call it option A. So for this option A, if you see m is greater than equal to n, so what I can do? I can write it a star a power n b power n. Do you agree? Because anyway, m is greater than equal to n. So this is what I can write. This language I can write like this, that this is a star, then a power n b power n, where n should be greater than equal to 0. Now you notice what I can do. This a star I can generate from a, this I can generate from x. Okay, this I can generate from x, from variable x, and this a power n b power n, they depend on each other. I have, okay, number of a equal to number of b. So this number of a equal to number of b, this I can generate from variable y. Okay, so finally what I need, remember I need xy. Okay, because I need xy, a star a power n b power n. So this a star I am generating from variable x, this a power n b power n I am generating from variable y. So finally I need s equal to xy. What x should give me? X should give me a star. Okay, for a star, this is a standard grammar, that is ax or epsilon. Yes or no? Ax or epsilon. So you can see this will give you a star. And what y should give you? Y should give you a power n b power n, where n is greater than 0. N is greater than 0. Okay, so you can see the standard grammar, that will be a power n b power n. The standard grammar is for every a there should be a b. Okay, but n is greater than 0. So at least AB should be generated. You cannot generate empty string. Yes or no? At least AB should be generated. So finally, this will be your grammar for this option A. Okay, so remember, in the grammar, what changes you need to do to get option A? These are the changes. This A you will make epsilon. Okay, this A you make it epsilon, and this you make it AB. Now this grammar will give you what? This will give you the answer option A. Okay, now the answer for this grammar, the answer will be option A. Okay, now understood? Let me know. Now tell me, in the grammar, what changes should I do so that I can get answer option B? Let me know. In the option B, what I want m greater than equal to n. In the option B, I have a power m, b power n, where m is greater than equal to n, and remember n is greater than equal to 0. Okay, so what changes should I do? Remember, I need m is greater than equal to n, because m is greater than equal to n and I have a power m, b power n. So if you look at, can I say that it is basically, can I write that this option b is like a star a power n b power n? Yes or no? Agree? Do you agree with me that we can write like this? Because remember, I want m is greater than equal to n, means it is possible that m can be equal to n. So what I can do, basically I have some extra zeros, but extra zero can be zero also. Okay, maybe there is no extra zero, so you can see this m greater than equal to n, I can write like this: a star a power n b power n. Now you can see this a star I will generate from variable x, and this a power n b power n greater than 0. Okay, this I will generate from variable y. Okay, so finally what changes should I do? I want, from x I want a star. Okay, so this a I will change to epsilon. Is this clear? This I will change to epsilon. Very simple. And remember, what else I need? Okay, what else I need? I need a power n b power n, so that is already fine. Okay, that is already fine. So now this grammar, what it will generate, tell me. Now this grammar will give you the answer option b. Okay, is this clear? Tell me. I hope you are understanding the analysis. Now you tell me about the option D. Tell me, what changes should I do in the given grammar so that I can get answer option D? Because if you look at option D, that is a power m b power n. Okay, and remember, here m is greater than n and n is greater than 0. Okay, so here if you look at m is greater than n, okay, and I have a power n b power n, so from here you can easily see that I can write it a plus a power n b power n. Okay, because I need more a's than b's. Okay, so remember, the number of extra a's should be at least 1. Okay, so that is the reason. Now you can see n is greater than 0. Now it is very simple, this a plus I can generate from variable x, and this a power n b power n greater than 0, this I can generate from variable y. Okay, so what changes should I do? Very simple, this is already generating a plus. Okay, so there is no change here, but there is a change here, because I want n greater than 0. I want a power n b power n greater than 0. Okay, so the change will be here, that at least ab should be generated. Correct? Yes or no? Now you can notice, if you take this grammar, then your answer will be option D. Okay, I hope you understood. This is the complete analysis of this gate exam question. Very simple. You can see what changes you need to do in the given grammar, so that answer will be option A, option B, option C, option D. Okay, understood? But for the original gate exam question, the answer will be option C. Let's solve these two gate exam questions. We have gate 2006 question, also gate 2009 question. So the same question has come in the gate exam 2 times. You can see the same grammar is given to you. Okay, similar grammar is given to you. So let's solve them one by one. Let's solve gate 2009 question. The given grammar is S is going to A as A, B as B, or A comma B. Actually, this is a standard grammar for odd palindromes. Yes or no, odd length palindromes. Okay, so the answer for this question, what it will be? This is a standard grammar, remember. We have already seen this grammar in our lectures, in our context-free grammar lectures. Okay, so this grammar is a standard grammar for odd length palindromes. The answer will be option B. But let me explain that this grammar is for odd length palindromes. Let me explain. You can see, look at this grammar. We have A as A, means if you start with A, then you end with A. We have B as B. If you start with B, then you end with B. And then I have A comma B. Okay, so if you look at this grammar, what strings it will generate? Okay, so from this S, what strings can I generate? You can notice that the strings I can generate will be like this. See, I can start this S, I can replace with A as A. Yes or no? So you can notice, if I start with A, for example, very simple point, this S, if I replace with A as A, means if this is my first production, then what will happen? Then it will happen that this s in between this s I can replace with anything. But remember, I will start with A, I will end with A. Yes or no? So the string I will get will be like this: I will start with A, I will end with A, and there is s in between. Now what I can do, this s I can replace with A as A or B as B. Yes or no? Or I can replace with A or B. So you can see this s I can replace with either A as A or B as B. So let me replace this s with A as A. This s I am replacing with A as A. Okay, A as A, like this. Is this clear? Now again, what you can see that if this is a, this is also a. Now what I can do, this s I can replace. Okay, so let me write it that this s I can replace either with asa or bsb. Let me replace with bsb. Okay, if I replace with bsb, then what you are getting, then you can notice if this is b, this is b. Okay, you are understanding my point that basically I am getting palindrome. Okay, if the first symbol is a, the last symbol is a. If the second symbol is b, the second last symbol is b. Okay, if the third symbol is b, then the third last symbol is b. So basically here I am getting the odd length palindrome. Why odd length palindrome? See, here I am getting the palindrome that is clear. Here I am getting the palindrome that is clear, because you can see whatever symbol you take, like first symbol is similar to last symbol, second symbol is similar same as second last symbol, third symbol same as third last symbol. So this s again, if you replace, for example, maybe this s you want to replace again. Okay, let me replace this s, you can replace with, for example, either asb or bsb. So let me replace with asa. Okay, let me replace with asa. Again, here you can see that for this a I am getting a. So notice one thing, very simple point, that okay, I am getting aaba, and here also I am getting aaba. So you can see the fourth symbol is same as fourth last symbol. Okay, so finally you can see that I am getting palindrome, but notice one thing, at the end this s I can replace with ab, a or b, yes or no? At the end, this s at the end, what I will replace, either I will replace with a or b. So I will get odd length palindromes, yes or no? So this type of strings I am getting where I have palindrome w. Okay, remember, from this s I am getting this type of string. I have w, I have this w, let's call it w. Okay, let me call it w. So this is w reverse, this is w reverse. So w reverse, but in between at the end, this s I can replace with a or b. Either I can replace with a or I can replace with b. So this will give me odd length palindromes. Understood? Okay, so this is going to give me odd length palindromes. So this is your answer. I hope you understood. Final answer will be odd length palindromes. Tell me what are the counter examples for option A, C, D. Let me know. Let's find the counter examples. We have already seen the answer, because here this will give you palindrome. Remember, this will give you palindrome. This will give you palindrome, and because of this, it will become odd palindrome. Because of this, it will become odd palindrome. Okay, understood? So you can easily see. Now, tell me what are the counter examples for option A. For example, option A is saying all palindromes. Okay, so tell me, from the given grammar, can I generate double A? Let me know. This is the given grammar, A as A or B as B or A or B. Tell me, from this given grammar, can I generate all palindromes? The option A is saying all palindromes. So can it generate from this? I can never generate AA. Can I generate double A? Because you can easily see, if I want to generate double A, remember, then this s double A is already there, but this s I will replace with A or B. So I will get triple A. Remember, okay, from here you will get A, you will get B, you will get triple A, you will get ABA, you will get BAB, you will get BBB. So this type of strings you will get, but you will never get A. So definitely this option A is wrong. Okay, what about option D? Option D is saying all even length palindrome. This is also wrong. Why? What is the reason? Because you can see this I cannot generate. I cannot generate double A. The counter example is, okay, the counter example, that is a double A. This is the counter example, double A. Okay, here also the counter example is double A. Double A is the counter example. And what about this option? This is saying strings that begin and end with same symbol. So according to this option, this option, I should be able to generate this string A, B, A. Can I generate this string? See, according to this option, this is saying strings that end and begin and end with same symbol. So according to this option, I should generate A, B, double A. But from this grammar, I cannot generate A, B, double A. Okay, is this clear? So that is the reason option C is also wrong. So this is the complete analysis of this question. I hope you understood. Now let me tell you one thing. See, this we have already seen in our lectures also, but you can easily understand that this is a standard grammar for palindrome. Basically, if you want to create a palindrome, then remember, the first and last symbol must be same. If the first symbol is A, then the last symbol must be A. In between, you can create palindrome. If the first symbol is B, last symbol must be B. In between, you can create palindrome. Okay, so remember these two productions. Okay, on your screen, these two productions, if you see, they will actually give you palindromes. Okay, they will actually give you palindromes. Okay, because very simple. What the definition of palindrome? The definition of palindrome is very simple, that if the first symbol is A, then the last symbol must be A. In between you can create palindrome. Yes or no? In between you can create palindrome. Or if the first symbol is B, then the last symbol must be B. In between you can create palindrome. Now notice what I am saying. This palindrome you replace with S. Okay, this you represent by the variable S. If I replace this by the variable S, then what I will get? Now you can easily see, I will get that S is going to, because this palindrome I am replacing with variable S, means palindrome is represented by variable S. So this S is going to A S A, because this palindrome I am representing by the variable X, by the variable S. So you will get A S A or B S B. Okay, because this PL palindrome I am representing by the variable S, so you can see I will get B S B. I hope you are getting the point. So remember, this ASA BSB, this will generate the palindrome. These two, these two will generate the palindrome. Okay, now if you want even palindrome, then you just put epsilon. After generating this type of palindrome, at the end, in the middle you just put epsilon. Okay, is this clear? So this epsilon if I put, then I will get even length palindrome, because you can see what S will generate. S will generate something like this, that W, and then there will be W reverse, there will be W reverse, in between there will be S. Okay, so this S I can replace with epsilon, this S I can replace with epsilon, so that I can get W W reverse, which is the even palindrome. So this is what I'm saying, that this will generate palindrome, and this epsilon will bring you even palindrome. Okay, but if this epsilon you replace with A comma B, then they will give you odd palindrome. They will give you odd palindrome. What the idea? The idea is very simple. Remember, from this S you can generate W, there will be W, there will be W reverse also. Okay, and in between there will be S. Now you can notice, if this S I replace, because already I'm getting even palindrome, I want odd palindrome, then this S I can replace with A or B. Okay, so remember, this A comma B, this is giving you odd palindrome. So finally the conclusion is this, that if I put A comma B, then I'm getting odd palindrome, and if I put epsilon, then I will get even palindrome. So okay, let me write like this, epsilon. Because of this you will get even palindrome. And remember, if you put odd also, even also, now you will get all the palindromes. Okay, now if you put all the three, if you put all the three here, all of them if you put, then remember, now what you will get? Now you will get all the palindromes, because now you will get even palindrome also, odd palindrome also, so you will get all the palindromes. Very simple. Okay, now let's solve this question. This is GATE 2006 question. This is also based on the same palindrome language. Here you can notice this ASABSB, they will give you palindrome, and remember what this will give you. This will give you all palindromes. Yes or no? Is this clear? I told you that S going to, if you start with A, you should end with A. If you start with B, you should end with B. Now remember, if you see this epsilon, these three will give you even palindromes. And if you put A or B, these will give you odd palindromes. Okay, so remember, because of because of these two, you are getting palindrome. Okay, because of this epsilon you are getting even palindrome, and if you put A also, B also, then because of these two I am getting odd palindromes. Okay, so because of all these three I will get all palindromes. Understood? Simple, right? So finally your answer will be what? Which is not generated by the grammar, that will be palindromes are generated. All the palindromes are generated. So actually this will be generated. Okay, this will not be generated. So the answer will be, the question is asking which is not generated. This is not generated. Remember, this will be generated, this will be generated, because this is also palindrome, you can see. Okay, this is BAB. Okay, it is like odd. This is odd palindrome, right? You can see BABA, BABA, and there is O, there is A. So this is actually odd palindrome. This is odd palindrome. This is even palindrome. Sorry, this is even palindrome. This is even palindrome. So the answer will be option B. Is this clear? Please tell me. So very simple point. I hope you understood. What about this epsilon? Is this palindrome? What about this one? Yes, this is a palindrome. This is even palindrome. This is a even palindrome. Okay, because you can easily see, if you, what is the definition of palindrome? Please understand. The definition of palindrome is that W is equal to W reverse. Okay, this is the definition of palindrome, that W is equal to W reverse. And what is the even palindrome definition? Even palindrome definition is W is equal to W reverse and length of W is equal to even. Yes or no? Is this clear? So remember, the definition of palindrome is W equal to W reverse, and the definition of even palindrome, that is W equal to W reverse and the length must be even. Now you can easily see in this epsilon. Okay, for this epsilon, what happens? Okay, this W is equal to epsilon. Okay, so let's take W equal to epsilon. So first of all, length of W is even. Also, you can notice that W is equal to W reverse, because you know that epsilon reverse is equal to epsilon. Okay, is this clear? So remember, this epsilon, this has even length. The length of epsilon is even, and W equal to W reverse, because epsilon reverse is equal to epsilon. So remember, epsilon is a even palindrome. This is not a odd palindrome. Epsilon is not a odd palindrome. Yes or no? This is not odd palindrome. Okay, very simple. Now let's move on. Let's solve this GATE 2016 question. Which of the following language is generated by the given grammar? This grammar is given to us. Which language is generated? You can easily see this grammar is actually regular grammar. Actually, this is a standard grammar. S going to AS, BS or epsilon. This is a standard grammar for sigma star. Okay, we have already seen in the lectures. This is a standard grammar. And what this will generate? This grammar, it will generate A or B whole star. Okay, this is what it will generate. So finally, your answer will be option D. Is this clear? Okay, so let me explain. This grammar is given to us. S is going to either AS or BS or epsilon. Okay, so actually you can easily see, you can generate any string you want. Okay, if you want, you can generate any string. Actually, what the idea? Why it can generate any string? Let me tell you. Because if you want to write regular expression for, sorry, grammar for A or B whole star, let's assume your language is A or B whole star. Let me explain the idea. See, this language is sigma star. Yes or no? And sigma star contains every string. Yes or no? So basically, in the sigma star, basically every string is there. It can generate any string. Sigma star can generate any string. So remember, our grammar should be able to generate any string I want. Yes or no? Okay, if this is your language and you want to write the grammar for this language, then remember, I should be able to generate any string I want. Yes or no? We should be able to generate any string we want. Okay, so actually, when you want to generate any string, then can I say, please notice the idea. The idea is very simple. If you want to generate any string, then can I say that you start with A, then you generate any string, or 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 you start with B, then you generate any string. Do you agree with me? Or 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 empty string. Okay, so this is the idea. I hope you understood. See, this is the language sigma star A or B whole star. Okay, and for this language I want grammar. Then I am saying that sigma star can generate any string. So my grammar should be able to generate any string. Okay, my grammar should be able to generate any string I want. So this is the idea. See, the idea is simple, that any string means what? If I want to generate any string I want, then what I can say, either it will start with A or it will start with B. Yes or no? So if it is starting with A, after that I can generate any string. If it is starting with B, then after that I can generate any string, or I should be able to generate epsilon. Okay, so this is the idea. Now you notice this, any string I want to generate, my grammar should be able to generate any string, remember. So this I will represent from variable s, means in my grammar, the start variable should be able to generate any string. Yes or no? In the grammar that I will write, in the grammar, the start variable should be able to generate any string. So this any string is represented by variable s, or I can say the variable s should generate any string. Okay, so now you can easily see the grammar will be what? Now, what will be the grammar? Now you can easily see the grammar will be that s any string is equal to a followed by any string. But remember, any string is represented by s. Yes or no? Any string, this is represented by s. Okay, so you can see this any string I can replace with s. This any string I can replace with s. So finally I can say s is going to a followed by s, or b followed by s, or epsilon, Okay, is this clear? So you can see this is the grammar. This is the grammar for a star, a or b whole star. I hope you understood the idea. Very simple idea. So very simple. Actually, if you have any confusion, you can write some strings and you can check from this grammar what the language generated. Okay, and let me give you a standard template. Instead of this as or bs, if you have, for example, let's assume you have this type of situation, that rs or ts, then let me tell you, this is a standard template to generate r or t whole star. Okay, this is a standard template, because remember, you can generate r or t whole star from here. Okay, you can generate, for example, from a string, from the start variable. From the start variable, I can generate epsilon, I can generate a, I can generate r, I can generate t, I can generate rr, I can generate tt, I can generate rt, I can generate tr, and so on. Basically, any sequence of r comma t I can generate. So this is actually a standard template. Okay, similarly here also you can see that here what I can generate from the start variable s, I can generate epsilon, I can generate a. Okay, what I can do, this s I can replace with epsilon, I can generate b, this s I can replace with epsilon, I can generate double a. Okay, I can generate ab, I can generate ba, I can generate bb, anything I want I can generate. For example, if you want to generate any random string like a b, let's assume this string you want to generate, then what you need to do, very simple. From s I will go to s, I will go to as, because the first symbol must be a. Now this s I can replace with, okay, the first symbol must be a. This s I can replace with bs, because the second symbol must be b. Okay, now this s I can replace with what? This s I can replace with, the third symbol must be a, so I can replace this s with as. Then the next symbol must be a, so this s I can replace with as, so it will be like this. And the last symbol I want b, so this s I can replace with bs. And finally, this is the string I want, so this s I can replace with epsilon. Okay, this s I can replace with epsilon. So finally what I will get, I will get ab double ab. Okay, is this clear? So whatever string you want, you can generate from this grammar. From this grammar, the language will be what? That will be sigma star, or I can say that will be a or b whole star. Okay, understood this? And don't forget about this template. Let me write it, a general template. It will help you in many questions. Okay, so let me write a general template. This is a standard template, that if you have s going to, for example, rs or ts epsilon, okay, you must have rs ts epsilon. If you have this type of situation, then what will be the language? So you can see that will be r or t whole star, because you can generate any sequence of r comma t. Okay, from this you can generate any sequence of r comma t. This will generate any sequence of r comma t, whatever sequence of r comma t you want, that you can generate. Okay, let me give you one example. For example, if your grammar is like this, that as or bbs or epsilon. Okay, now you can notice this is the r, this is the t, yes or no? So you can generate from, this is the standard template, and what is the language you can generate? Any sequence of r comma t. So it will be r or t whole star, because from this grammar you can generate any sequence of a comma double b. You can generate any sequence of a comma double b. Okay, of course you cannot generate bab, because remember, this double b, this is a single atomic entity. You can consider that this is the single entity, this is the single person. So any sequence of a comma double b you can generate. Okay, very simple. So let's come back to this question. So for this question, the answer will be a comma b whole star. Okay, this is the standard grammar, remember, as bs epsilon. So your answer will be option d. Okay, understood? Can you give me the counter example? Can you do option elimination? Let's see. Can we eliminate the options? Let's see. From the given grammar, this is the given grammar. From this given grammar, if I want to eliminate the options, then what I can do? See, option A is saying that only these strings I can generate. Option A is saying I can generate a power n, b power m, where basically this is option A. Option A is saying a star, b star. Yes or no? This is what your option A is saying. This is a star, b star. That only these strings I can generate. But you can notice that from this I can easily generate BA. This string I can generate. Do you agree with me? Okay, yes or no? Because notice what I can do. I can do like this. Okay, in this what I can do, S can go to BS, this S can go to AS, so it will be like this. This S can go to epsilon, so I will get BA. Okay, yes or no? So remember, BA can be generated from the given grammar, but you can see option A does not have BA. Okay, from here I cannot generate BA, so that is the reason option A is gone. Option A is eliminated. What about option B? Tell me, anyone? Option B is saying that equal number of A comma B. This is actually non-regular language. Equal number of A comma B. If you look at this language, this is a non-regular. Okay, agree? This language is a non-regular, but the given grammar is actually regular grammar. If you look at this grammar, this is actually right linear grammar. Yes or no? This grammar, this is a right linear grammar. Every right linear grammar is regular grammar. So actually, this is regular grammar. Okay, so the language must be regular. Yes or no? Okay, because this is because this is regular grammar and this is right linear grammar. You can see every production, every rule, every production has at most one variable on the RHS, and that variable is on the rightmost position. So this is right linear grammar. Every right linear grammar is regular grammar, and regular grammar will generate regular language. Yes or no? Regular grammar, it will generate regular language. It will always generate regular language. So definitely option B is not the answer, because option B is non-regular grammar, non-regular language. Option B is non-regular language. So definitely that is not the answer. Actually, if you notice, option C, option C is also non-regular language. Yes or no? Look at option C. That is A star or B star or A power n, B power n. So if you look at option C, that is also non-regular language. Understood? Please tell me. Because if you look at option C, that is A star or B star, or there is A power n, B power n. Okay, yes or no? N is greater than equal to 0. So because of this A power n, B power n, okay, you have to calculate. You have to keep track of number of A's, because number of A must be equal to number of B's. Yes or no? If you have 100 A's, then you must have 100 B's. If you have 1000 A's, then 1000 B's. So you can easily see that option C, that is actually non-regular language. So that also can never be the answer. Yes or no? Is this clear? Because the given grammar is regular. This given grammar is right linear grammar. Every right linear grammar is regular grammar. So the language will be regular language. But option B comma C, they are non-regular languages. So they can never be the answer. Yes or no? And remember, if you want counterexample for option B also, you can easily see that from the option B, I can never generate this string A double B. Yes or no? Or I can, in simple words, I can never generate string A. Yes or no? From the option B, I cannot generate this string A. But from this grammar, I can generate string A. So that is the counterexample for option B also. What about option C counterexample? See, option C, if you look at, option C is saying that A star or B star or A power n, B power n. Okay, so you can easily see that from option C, I can never generate this string BA. Yes or no? I can never generate a string BA from option C. But you can notice that from here, from the given grammar, I can generate BA. Okay, yes or no? And so that is the reason option A, option C, those are also wrong, because from option A, I can never generate BA. So my answer will be option D. So to solve the same question, many methods are there. Yes or no? You can either eliminate the options, or you can see that the given grammar is regular grammar. So the language will be regular. So you can see option B comma C are non-regular languages, so they are gone. Or you can see that this is the standard grammar for A or B whole star. This is the standard grammar for sigma star. So to solve this GATE 2016 question, there are many methods. If you want to do the complete analysis of this question, then this is what we have done. Every single point related to this question I have told you in this complete analysis. Okay. Now let's move on now. Let's solve this GATE 2016 question. So two grammars are given to you, G1, G2, and the question is asking you which of the following pair of languages is generated by the G1, G2. Remember what we need to find? We need to find which languages are generated from G1, G2. We have to find the language of G1, we have to find the language of G2. So let's find the language of G1. Now you notice one thing in this question, this G1 is given to you, and we need to find which of them is the language. If you notice, in all the options, what I have a power m, b power n, a power m, b power n, a power m, b power n. In all the options, this is common. So the only change is m greater than equal to 0, or m is greater than 0, n is greater than 0, n is greater than equal to 0. So basically, you can see n greater than 0 is also same. Okay, but there is or here, there is or here, there is and here. So basically, this is the only change. Now let me tell you, in this type of situation, what you can do. Notice all the options are similar. There is small difference. Basically, the small difference is from where it will start. Will you start from 0? Will you start from greater than 0? Okay. So what you can do, the best way in the gate exam to solve this question, because the options are like that, that is option elimination. You can see which strings are generated. Some small strings which can you generate. Tell me, what are the minimum length strings that I can generate? Notice S can go to B and B can go to B. So the minimum length string I can generate, that is B. This is minimum what I can do. Yes or no? This is what I can do minimum. From the given grammar, I can generate string B, because S can go to B and B can go to B. Next, you can notice S can go to B and B can generate B plus. Yes or no? You can notice. Look at the grammar G1. Here you have S is going to AS or B, and B is generating B plus. Okay, if you look at here, because from B I can generate B, double B, triple B, anything. Okay, I can generate B, I can generate B square, I can generate B cube, and so on. So you can see these strings also will be generated. Basically, B plus will be generated. Okay. Also, you can notice S can go to AS. Okay, and then S can go to AS, S can go to AS. Then this S can go to B, and then I can generate AB. Yes or no? You can see S can go to AS, and this S can go to AS, so I can generate A double S. Now this S can go to B, so I can generate this also. I can generate A cube B also. Okay, I can generate like that. Okay, anyway, now let's see which options are gone. Tell me which options are gone. Let's only talk about G1. Right now, I am only talking about G1. So tell me, from these, which options you can eliminate? Let me know. We can easily see what option A is saying. Notice, from option A, we are saying that m greater than 0 or n greater than 0. Either m is greater than 0 or n is greater than 0. So actually, from option A, I should be able to generate the string A. Can I generate string A? Actually, option A is saying either m greater than 0 or n greater than 0. Notice here, option A is saying either m is greater than 0 or n is greater than 0. So from option A, this string should be able to generate, but this G1 cannot generate. Yes or no? From G1, we can never generate the string A. So this option is gone. Okay, yes or no? Okay, what about the next option? You can see this is saying, look at the option D. Option D is saying that m is greater than equal to 0. Option D, that is saying m is greater than equal to 0. So tell me here, okay, m is greater than equal to 0. Yeah, that is fine. What about this one? See, option B is also gone, because from option B you can never generate B. Yes or no? Look at option look at option B. In the option B, can I generate B? Tell me. In the option B, because m is greater than 0, I must have m greater than 0. Okay. So you can see I can never generate this string B, but this is generated from G1. G1 can generate a string B, so option B is also gone. Okay, what about the option C? Option C is saying m greater than equal to 0, n is greater than 0. Okay, or there is or here. In option C, you have or. There is or, means either m is greater than equal to 0 or n is greater than 0. Okay, so what you can notice, that here you can generate A. Okay, from option C you can generate A. So that is the reason. Remember, this option is also gone. Your answer will be option D. Is this point clear? The remaining options you can easily eliminate. You don't even have to check G2. From G1 you can see that answer will be option D. Understood? Let me know, because remember, see, from option A I can generate A, but the given grammar G1 does not generate A. From option B I cannot generate B, but the given grammar generates B. From option C I can generate A, but the given grammar does not generate A. So these are the counter examples. Is this clear? So finally your answer will be option D. Okay, you don't even have to check G2. But anyway, we will do the complete analysis. Now let's see what is G1 and what is the language of G2. So let's see this G1. G1 is saying that I can replace this S with AS or with B. Okay. And remember, this B I can replace with B or BB. Okay, now let's see. Let's find what is the language here. You can notice this B does not depend on any other variable. This B only depends on B. No other variable. Yes or no? So tell me what this B will generate. Let me know. From this B, what I can generate? You can see from B I can generate B plus. Okay, because you can notice that from B you can generate B. You can generate, for example, BB, and this B you can replace with B. So double B also you can generate. Basically, from this B you can generate B, double B. If you want triple B, that also you can do. What you can do, notice, if you want triple B, that also you can do. This B I can replace with this B I can replace with BB. Then this B I can replace with B. So triple B also I can get. So the point is that from B I can get B plus. Okay. Now from this S, what I will get? Notice from this S. Okay, so let's focus on S. S can give you what? S can give you, for example, AS. Now this S I can replace with B. Okay, yes or no? Or what you can do, notice, this S I can replace with AS. So you will get double AS like this. Okay, and so on. Okay, finally remember, basically I am saying that S can give you A power n S. Okay, this type of strings, this type of things, this S can give you. And finally this S you will replace with what? You will replace S with B. Yes or no? Finally this S you will replace with B. So remember, from S I can, what I can generate? I can generate A power n S. And remember, finally this S I will generate, this I will replace with B. So it will be like this B. Okay, and if you notice, from S I can directly go to B. So I can generate B also, I can generate A power n B also. So tell me what S will generate ultimately. Let me know. So you can easily see that from here, let me tell you that B is giving you B plus. Okay, and what S is giving you? S is giving you B plus also. Remember, from S I can generate B also. I can generate A power n B also. Both I can generate. So basically I can say that the answer will be A power n, okay, B, where n is greater than equal to 0. Okay, and you can notice that this B will give you B plus. So finally you can easily write that this will be A power n B power m, where n is greater than equal to 0 but m is greater than 0. Okay, yes or no? And m is greater than 0. There is and here. I hope you understood this. So this is a very simple analysis. Nothing complicated here, remember, because already this grammar G1, in this grammar G1, remember, S has like this. S is generating AS or B. Okay, so let me tell you what this will give you. What this will give you? This will give you A power n B, where n is greater than equal to 0. Okay, is this clear? This is what it will give you. A power n B, where n is greater than equal to 0. Now this B is already giving you B plus. Okay, so your final answer will be, your final answer, the language of G1, that will be A power n B power m, where n is greater than equal to 0 and m is greater than equal to 1, or I can say m is greater than 0. So this will be your final language. Okay, understood? Simple, right? Yes or no? So that is the reason this will be your language. And which option will you get? We have already found the language. The language will be L of G1, that is A power n B power m. Okay, that is A power n B power m, where n is greater than equal to 0 and m is greater than 0. Okay, so which option is matching? Okay, so in all the options A power m is there. So let me change the powers. Okay, let me change the powers. If I change the powers, for example, if I make it m, if I make it n, okay, I'm just making m comma n, I'm exchanging. Okay, I'm exchanging m comma n. So it is like I'm exchanging m comma n. So this I'm making it m, This I'm making it n. Okay, I'm making this m, this n. Is this clear? So this will be the answer. You can see which option is matching. A power m, b power n, where m is greater than equal to 0 and n is greater than 0, and there is and here. Okay, so only this option is matching. Only option D will be the answer. Remember, option C has or. So this is also gone. Yes or no? Option C is gone, option B is gone, and option A is gone. Is this clear? Please tell me. Because here you have greater than 0, and you can easily see that here you have greater than 0 and here you have or. Here there is or. So you don't even have to check G2. You don't even have to check G2, because the question is asking what are the language of G1, G2 respectively. So this is the language of G2 and this is the language of G1. So your answer will be option D. You don't even have to check G2. But let's check G2 for complete analysis. We always want to do complete analysis. Getting the answer and moving on, that is not our purpose. Okay, somehow get the answer and then just move on. Okay, this is not our purpose. Actually, let me tell you what happens. Many students, what they do, they just eliminate the option. What they will do, option A, B, C, D will be given. What they will do, they will eliminate the options with some, with help of empty string, with help of A comma B, some small strings. So with the help of these strings, they will eliminate the options. Like for example, like this they will do, and then they will move on. They will not try to do the complete analysis. They will not try to find what is the language, okay, what are the options. Okay, so basically other than option elimination, they don't do anything. They just do the option elimination and then they will go to the next gate question. And this is the mistake. You should always do the complete analysis of every gate exam question. Okay, now let's see the analysis of G2. So this grammar G2 is given to us. Now let's see what language this G2 will generate. Let's check it out. So what you can do, again, for this G2 there are two ways. Either you can do the option elimination, or you can do the complete analysis. So first let me do the option elimination. I will focus only on G2. So let me remove these languages which are of G1. Okay, so let me remove these. Now tell me, from G2, which strings can you generate and which strings can you not generate? Notice all the options, if you see, these are A power m, B power n, A power m, B power n. Okay, so the only difference is here. What is the range of m? Okay, agree. So now tell me, which strings are generated from G2? This G2 will give you which strings and G2 will not give you which string. So you can see from G2, you can see either you can, S can go to AA, this A can go to B and B can go to epsilon. So basically from this G2, I can generate string A. Yes or no? S can go to A, this A can go to B, you can notice, and this B can go to epsilon. So A I can generate. Agree? Okay, what else I can generate? You can see S can go to BB and B can go to epsilon. So B also I can generate. Can I generate empty string? I can never generate empty string. Yes or no? Empty string cannot be generated. Okay, what about the other strings? For example, you can see there is A. Now, this A I can replace with B, and from here I can generate B. So AB is also generated. A is also generated. Is A generated? Tell me. What about double A? Like I can take AA. This A I can replace with this A I can replace with A. So I got A. Now this B can go to epsilon C. Yes, double A also I can generate. Okay, yes or no? What about double B? Tell me, can I generate double B? B. Yes, I can generate double B also. Okay, and what about BA? See, from here I can go to BB, and then from B, now I can never generate BA. Yes or no? So BA I can never generate this BA. This string I can never generate. Anyway, this is the idea. Now tell me which options you can eliminate. Notice what option A is saying. Option A is saying that m should be greater than 0 and n should be greater than 0. So from option A, can you ever generate string A? Tell me. From the option A, can you ever, in the option A, do we have string A? Tell me, because you can easily see option A is saying m greater than 0. This is greater than 0 and n greater than 0. Both are greater than 0. So we don't have A, we don't have B. Yes or no? Is this clear? But actually the grammar is generating A comma B. So this option is gone. Understood? Okay, what about the next? What about option B? From the option B, we can never generate. Never, option B is saying m is greater than 0. This must be greater than 0. So from here, we can never generate B. Do you agree with me? From, sorry, there is or here. There is or here. In here, we have or. Okay, there is or. So basically either m is greater than 0 or n is greater than equal to 0. Okay, so from here actually either m greater than 0 or n is greater than equal to 0. Actually from here epsilon can be generated. Yes or no? Because there is or here. Notice what I'm saying. I'm saying that m is greater than 0. It is like a power m b power n, where m is greater than 0 or there is or here, n is greater than equal to 0. Now you notice this empty string will satisfy this condition. Yes or no? In the empty string I can say a power m b power n, where you can see that n is greater than equal to 0. Yes or no? So there is or here. Are you getting my point? Okay, so empty string will satisfy this condition, because in the empty string you can easily see that this is also 0, this is also 0, but there is or here, that either this would happen or this would happen. Okay, so you can see that from, look at this option B can generate empty string, but the grammar is not generating empty string. We cannot generate empty string, okay, from the grammar. Now what about option C? You can see in the option C we have and this is saying m greater than 0 and greater than 0. Again this option is gone, because we can never generate from the option C, we can never generate string a comma b. These strings we can never generate. Okay, so these options are gone. So finally your answer will be option D, because the remaining options are eliminated. Okay, understood? Please tell me, let me know. Now let's do the complete analysis of this question. So the grammar that is given to you G2, let's see directly how to find the language. So remember S can go to AA or BB. S can go to AA or BB, and A can go to AA. Okay, and remember, or B or epsilon. Okay, next you can see B can go to BB or epsilon. B can go to BB or epsilon. Okay, so this is the given grammar. Now you can easily see here that this B does not depend on any other variable. You can see this variable B, this does not depend on any other variable. Okay, so what this B is generating? This B is generating B star. Okay, agree? From B you are getting B star, because you can easily see that from B I can generate empty string, I can generate B, I can generate B square, I can generate B cube, and so on. So B is generating B star. Okay, now you focus on A. What A is generating? Let's focus here. What A will give you? See, A will give you empty string. A will give you what B is giving you. A will also give you AA. Okay, so actually it is like this. See, from A, if you notice, let me explain. If you have this A going to AA or B or epsilon, okay, so let's look at from this what you will get. From this you will get A power, you will get AA. Now this A I can replace with what? This I can replace with AA. This A I can replace with what? This I can replace with A. So this is the idea that from A you are basically getting A power n, okay, and then A. Yes or no? This is what you are getting. Is this clear? This is what you are getting. And finally this A either you are replacing with B. Finally either you are replacing with B or you are replacing with epsilon. Is this clear? Either you are replacing with B or you are replacing with epsilon. So finally here I can say from A what you can generate. Remember you can generate A power n A, okay, A power n. But remember this A you can generate, this A you can replace with epsilon also. Okay, so this A you can replace with epsilon also. So basically you are generating A power n also. Okay, and you can see you can directly go to B also. So you can directly go to B also. Okay, and this A I can replace with B, so I can say it is like A power n B. So these things you can generate from A, and remember n is greater than equal to 0. Okay, is this clear? You can easily see n is greater than equal to 0, because remember we can generate epsilon also, we can generate B also. I can generate epsilon, I can generate B. Okay, so n is greater than equal to 0, because I can generate B. So that is the reason n is greater than equal to 0. Is this clear? So this is what A is generating. Remember, A is generating A power n B or A power n or B. So finally, in one word, what I can say what A is generating? In one word, I can say A is generating A power n. And remember, already we have already seen what B was generating. B was generating B star. B was generating B star. Okay, so this B was actually generating B star. Here n is greater than equal to 0. So actually in one word I can say that A is generating, finally I can say that A is generating A star B star. Okay, is this clear? A is generating A star B star. Please tell me, did you understand? Let me know. From A, I can generate A star B star. This is what I can generate from A. Okay, just think about it. This is not complicated. You can take your copy pen and you can easily see. Because remember, from A, I can generate B directly. Okay, so I can generate B star. Okay, yes or no? And you can generate A star also. You can generate A star B star also, because A power n is greater than equal to 0. Okay, so this is basically A star B star. Okay, understood? Now let's come back to the question. So yes, now let's come back to this one. So we have already seen what this A will give you. We have already seen. Now let's see the next. So finally, this A, what A will give you, we have seen this will give you A star, B star. This is what A will give you. Okay. Now you tell me what S will give you. Because the language will be what this start variable will generate. Yes or no? Whatever strings the start variable will generate, that is your language. So tell me what start variable will generate. You can see either start variable will generate AA or it will generate BB. Understood? Please tell me. So remember, from the start variable what you can generate, let's write it. From the start variable, you can notice either I can generate BB, that simply means B plus, yes or no? BB or AA. Now, B is already giving you B star. We have already seen B is giving you B star. So finally, and what A is giving you? A is giving you A star B star. Okay, so tell me what S is giving you. From S, you are basically getting B plus or either B plus or what you are getting? You are getting A plus B star. Yes or no? So either you are getting B plus or you are getting A plus B star. Understood? Please tell me. Let me know. So finally, let me write it that from here, finally you are getting that S is giving you what is your language. Let me write the language. The language is B plus or or A plus B star. Okay. Now in one line I can write it like this, that I am basically getting A power m B power n. Okay. Remember, either I am getting this means here there is no A. Yes or no? Either there is no A. Either there is no A. So means I can say that either this or this. There is or here. Are you getting my point? Either this or this. So remember, because this means or. So this means or. So I can say that either there is no A means m is greater than equal to 0. Either there is a no A. Okay. So m is greater than equal to 0, because if m is 0, then those strings are here. Okay. Understood? And you can see if m is 1, if m is greater than 0, then these strings are also here. Okay. Or what can happen? Or what can happen? Or it can happen that n is greater than equal to 0. Okay. Because you can notice if I put n equal to 0, notice if I put n equal to 0, then those strings, sorry, this is wrong. Okay. N is greater than 0. Either m is greater than equal to 0 or n is greater than 0. See, I cannot write greater than equal to 0. Why? What is the reason? Because if I write this, then what is possible? Then string A is possible. Yeah, string A should be there. If I write this, then empty string is also possible, right? Let's see what we are doing. Either m is greater than. Okay, see, empty string is not generated here. So what I can say? I can say that this or this. Okay. So what can I write it? Let's write both of them in form of A power A star B star type. Okay, so let's write. So can I say that this can I write A power 0 B plus? Can I write like this? Or A plus B star? Okay. Is this clear? Now, if you notice, from here I can get a plus. So let me write it separately. I can say that I am getting b plus. Notice, I can say I am writing b plus. Okay, here I am writing b plus. Here, if I don't take this, then I will get a plus. And if I take this at least one time, then I will get a plus b plus. Okay, now this is fine. Now basically you can see that what will be your answer? Answer will be a power m b power n, where either m is greater than 0 or n is greater than 0. Okay, is this clear? See, very simple point, because you can notice this b plus is same b plus here. Okay, from here what I can do, I can write it a plus or a plus b plus, because if I repeat it 0 time, if I take it 0 time, then I will get a plus. If I take it at least one time, then I will get a plus b plus. So now you can see I have a plus or a plus b plus or b plus. Okay, means at least one of them is greater than 0. Do you agree? Yes or no? Is this clear? At least one of them is greater than 0. You can see at least one of them is greater than 0. Please notice our language we got. If you see our language we got, that is b plus or a plus b star. I can write it b plus or a plus or a plus b plus. Now you can easily see that whatever you see here, you can notice that at least one of them is greater than 0. Okay, you can notice that either number of a is greater than 0 or number of b is greater than 0. Is this clear? So this is what I'm saying, that basically the strings are like this: a power m, b power n. Okay, this type of strings you have, where either m is greater than 0 or n is greater than 0. Okay, is this clear? So this will be your language. I hope you understood. So finally your answer will be, you can notice, either m is greater than 0 or n is greater than 0. This is for G2 and this is for G1. Your answer will be option D. Understood? Please tell me. So like this you can do. Now let's move on now. Let's solve this GATE 2017 question. And this is a very beautiful question. Many students, they can make silly mistakes in this question. So consider the following context-free grammar. This grammar is given to us on the alphabet A, B, C. S is the start variable. Which of the following represents the language generated by the above grammar? Okay. So this question you can solve by many different methods. Okay. Now let's see. First we will do the complete analysis and then we will see the option elimination also. Okay. So this grammar is given to us as, this is the start variable. S is going to A, B, S, C, T. Okay, A, B, S, C, T or A, B, C, T. A, B, C, T. And T is going to B, T or B. Okay, so this is the grammar. Now you can easily see from this grammar, you can find what is the language. First you focus on this T, because this T does not depend on any other variable. You can notice this T, this variable T does not depend on any other variable. This does not depend on S. Okay, so you tell me what T will give you. Let me know what this T will give you. This T will give you B plus, yes or no? Because from this T, I can generate B, I can generate B square, I can generate B cube and so on. Okay, so you can see this T will give you B plus. Okay, that is fine. Now we know that this T is going to give us B plus. Understood? Okay, so now you tell me, this T you can remove now, because remember we already know what T will give you. When you go to T, then T will always give you B plus. Okay, at least one B. B plus means at least one B. T will give you at least one B. Okay, so now you tell me what S will give you. In this S, you can notice here S is repeating. Here we have the basically the recursion. You can see there is a recursion of S. S is going to S. So there is recursion here. And this is the termination condition. Can I say? If this S is going to S, you can notice, then this S will keep going to S. Ultimately, this S you will replace with A, B, C, T. That will be your termination condition. Agree? Yes or no? So very simple point, that this is basically the termination condition for recursion of S, because S is going to S. Okay, so tell me what S will generate. You can easily see. Okay, S will generate from here that for every AB you are getting a CT. It is like this. For every AB you are getting a CT. See, it's like this. When you write like this, that S is going to A, S, B, and then there is something here. Okay, then there is something here. Let's assume anything Y. Now you tell me, Here what happens? Basically for every a there is a b. Yes or no? What will be generated here? Here a power n s b power n will be generated, because you can easily see that s will go to as b. Now already this ab is there, but this s will go to as b. So you are getting a power n s b power n, and finally this s you can replace with y. Okay, and remember from s you can directly get y also. So finally I can say that in this type of situation, in this type of situation, this is what s is generating. Okay, so what will be the language? Means I can say what s will generate. S will generate basically a power n y b power n, where n is greater than equal to 0. Okay, is this clear? Because we can directly create y from s, we can directly create y, so that is the reason n is greater than equal to 0. Okay, agree? So very simple. I hope you understood. Now let's see in this one. Okay, so in this what will happen? So here you can notice that for every AB you are getting CT. You can understand that it is like, you can easily see that S will be like this, that for every AB you are getting a CT and there is S here. Now again this S I can replace with, you can see that there is already ABCT, there are already there. This S I can replace with ABSCT. So can you notice I am getting AB power n, CT power n? Yes or no? Is this clear? For every AB you are getting CT. It is like this, that from here I can say that you will get AB power n S CT power n. Okay, is this clear? This is what you will get. And remember, from S I can directly create ABCT also. Okay, so I hope you understood this. So far you understood this. Tell me that from S what I can generate. So remember, from S I can generate AB power n S CT power n. Okay, and remember, this S can go to ABCT. ABCT. S can go to ABCT. So now this S I can replace with ABCT. Okay. So if you replace this S with ABCT, then what S will give you? S will give you AB power n. Then there is ABCT, and then there is CT power n. Okay, agree? This is what S will give you. And remember, S can also go to ABCT. Okay, so this also S can go to ABCD. So can I say n is greater than equal to 0? Because remember, S can go to ABCT also. So can I say this n you don't need? This n can be 0 also. Agree? I hope you are getting the point, because S can go to ABCT. This variable S, this can go to ABCT. So this is what I'm saying, that because S can go to ABCT, so this n I can take 0 also. So that is the reason I can say that n is greater than equal to 0. Okay, understood? Now you notice this is n is greater than equal to 0. Okay, and there is this combination and this combination, I can combine them. So what you will get if I combine them, because there is at least one AB, there is at least one CT. See, this is n is greater than equal to 0. This n is greater than equal to 0. But if you look at this, it's like this. It is like this. You know that R star, if you have R star R, that is basically R plus. Correct? Okay, so what I can say? I can say that I can combine this, and I can say it will be like A power AB power M, or you can say N, no problem. And here I can combine this CT, this is CT, this is CT power N. Okay, so CT power N, where N will be what? N will be greater than equal to 1. Okay, is this clear? Very simple, right? Yes or no? Because you know R star R is equal to R plus. So just you have to put N greater than equal to 1. So finally, what this variable S is generating, this is generating AB power N CT power N, where N is greater than equal to 1. And finally, remember this T, what this T is giving you, we already know. We already know what T is giving you. T is giving you B plus. T gives us B plus. Okay, so let's write B plus. So you will get AB power N. It will be like C B plus power N, where N is greater than equal to 1. Okay, is this clear? This is your answer. Let me tell you, this is your answer. But in the options, you can see this is actually not given. This B plus is not given. In the options, this B plus is not given. Yes or no? Agree? This plus, this plus is not given in the options. Options are like B power M. Okay, so let me write it. Now you just tell me a simple point. Here something interesting. Some strings you generate and tell me some strings. Let me know some strings can you generate. For example, if I put n equal to 1, what strings I will get? Let me know. For n equal to 1, I will get a b c b power m, where m is greater than equal to 1. Yes or no? Can I say? Can I say? Tell me yes or no. Okay, now you tell me, if I put n equal to 2, what I will get? I am putting n equal to 2, so I will get ab power 2. I am putting n equal to 2, so I will get ab power 2 cb plus power 2. Okay, so can I write it like this, that will I get like this, that okay, cb power m, cb power m? Is this correct answer? Tell me, where m is greater than equal to 1. Is this answer correct? When you put n equal to 2, will you get this type of strings? Let me know. When you are putting n equal to 2, very simple question I'm asking, remember, you just put n equal to 2, so this will be 2, so you will be ab power 2. Okay, here also you put 2, so can I say that it will be cb power m, cb power m? M is greater than equal to 1. Let me know. Can I say this? Because b plus means what? B plus means, remember, you already know what b plus means. This means b power m, where m is greater than equal to 1. Okay, correct. What is b? What is b plus? B plus is same as b power m, where m is greater than equal to 1. So this is what I'm asking, that will you get this type of string? The answer is no. Okay, the answer is no. This is wrong. Why? What is the reason? Because notice, you will get like this. Actually, if you notice, you will get, if you put n equal to 2, let me put n equal to 2, you will get it like this, cb plus cb plus. Now tell me, this b plus and this b plus, do they have anything to do with each other? Will they repeat same number of times? Simple question I'm asking, and tell me, will they repeat same number of times? Tell me. I'm asking, this b plus, this b plus, will they repeat same number of times? No. This can repeat 2 times, this can repeat 4 times, this can repeat 10 times, this can repeat 2 times. Yes or no? This b plus, this b plus has nothing to do with each other. So can I write it that this is a b whole square? Then c b power some value m1, c b power some value m2, where m1 comma m2 are greater than equal to 0. So greater than equal to 1. Understood this? Please tell me. Let me know. Did you understand? Now you tell me, if you put n equal to 3, then what will happen? If I put n equal to 3 in this, okay, because this is the language I will get. So if I put n equal to 3, then what type of strings I will get? Let me know. You can put n equal to 3, so it will be like ab power 3. Then you can notice here, if I put 3, then what I will get? I will get cb plus, cb plus, cb plus. But remember, these cb plus, remember this b plus, this b plus, this b plus, they have nothing to do with each other. Yes or no? This can repeat, for example, 2 times, this can repeat 5 times, this can repeat 100 times. Yes or no? These they can repeat any number of times. So can I say that this is basically, it's like this, ab power 3, then there is c, then there is b power m1, c b power m2, okay, c b power m3, okay, where m1, m2, m3 all are greater than equal to 1. Okay, because you know what is b plus, you know what is b plus. B plus is b power m, where m is greater than equal to 1. Understood? Let me know. So I hope you are getting the point. So let me tell you finally what type of strings are generated from this. Okay, the language is actually, it is like this, a b power n. If I put n equal to n, okay, if I repeat it n times, then it will be like this, cb plus, cb plus, cb plus. How many times? How many times? N times. Yes or no? How many times? This will happen n times. Okay. So now you can notice that this b plus, this b plus, this b plus, and this b plus, they have nothing to do with each other. Yes or no? For example, this can repeat 2 times, this can repeat 100 times, this can repeat 3 times, this can repeat 1,000 times. Yes or no? Is this clear? So it is like this, that answer will be a b power n. Then remember, n times we have to repeat c b power m1, c b power m2, because they have nothing to do with each other. Yes or no? For example, this can repeat 2 times, this can also repeat 2 times, but if this is repeating 2 times, this can repeat 4 times also. Okay, remember they can repeat same number of times also, they can repeat different number of times also. So basically they have nothing to do with each other. So finally it is like cb power m1, cb power m2, cb power m3, and so on, cb power. Tell me how many? Because how many these we have? We have n times. Yes or no? See this. If you have 3 here, then m3. See this. If you have 2 here, then m2. So till how many times we will go? Let me know. If this is n here, so n times. So it is like this, n times mn. Okay, understood this? Please tell me, because remember this is repeating, this cb is repeating, this cb plus is repeating n times. So if I write it m1, then this will be m2. Okay, then this will be mn, where all mi are greater than equal to 1. Okay, is this clear? Where all mi greater than equal to 1. This is the language. So this is a beautiful question. I hope you understood. So finally, what is the answer for this question? Tell me. You can easily see the answer will be option B. Look at option B. Okay, see the option B is saying, in the option B we have a b power n. Yes or no? A b power n. Notice, and notice n should be greater than equal to 1. We have already seen n should be greater than equal to 1. This we have already seen. Okay, so you can see that n is greater than equal to 1. Greater than equal to 1. Okay, n is greater than equal to 1. And you can see after this ab power n, I told you what we will get. We will basically get cb plus power n. Okay, this is actually the answer. This is actually the answer. Okay, ab power n, cb plus power n. Okay, so from here what I can write it, I can write it ab power n, then cb plus and so on, cb plus how many times? N times. Okay, that you already know. N times. How many times? This this cb plus, how many times they are repeating? N times they are repeating. Okay, so in simple words I can say that ab power n, then cb power for example m1, cb power for example m2, cb power for example m3, and so on. Cb power mn will be there, where all the ni, where all the mi, these are also greater than equal to 1. So you can see the option B, this is the perfect option. Did you understand this? Please tell me. Let me know. Okay. I hope this point is clear. Now, let's see the counterexample for the remaining options. Let's see. For option A, do you have any counterexample? See, option A is saying that you have a b power n, c b power n, where n is greater than equal to 1. Okay. So according to this option A, let's focus on this option A. Which type of strings you can generate? You can generate only this type of string. For example, you can generate, if you put n equal to 1, then you can generate abcb. Okay, from this option A you can't even generate abcbb. Are you getting my point? From this option A we cannot generate, for example, this string. Look at this string ab cbbb, cbb. Okay, tell me, from the grammar can I generate abcbb? From the grammar can I generate abcbb? Let me check. You can see from S I can go to absct. Okay, now, or maybe from S I can directly go to abct. Abct, from S I can go to abct. I can go to directly abct. Now this t, now this t can go to what? Tell me. Abc. Now this t can go to bt, and now this t can go to b. Abcbb. Yes or no? Is this clear? So remember, from this grammar you can generate abcbb. This you can generate. Okay, but you can notice from the option A I cannot generate abcbb. So option A is gone. Okay, agree? Let me know. What about option B? Option B is the answer, we have already seen. What is the counter example for option C? Tell me. Option C counter example. Notice in the option C, what is the problem? I told you in option C, look at option C. In the option C we have a b power n, and then you have c b power m power n, where m is greater than equal to 1, n is greater than equal to 1. Okay, can you notice what is the problem with option C, where both are greater than equal to 1? Actually the problem was like this. If you remember, from the given grammar, if you remember from the given grammar, will generate a b power n c b plus power n. This is what your given grammar will generate. We have already seen the analysis. You can see your given grammar will generate this type of strings. Okay, if you open it, for example, let me open it two times. Okay, let me open it two times. If I put n equal to 2, then what should I get? I should get a b power 2, and then I should get c b plus power 2. And that is basically a b power 2 and then cb plus cb plus. Yes or no? Now let me tell you here in the option C, basically this b and this b, they are repeating same number of times. Are you getting my point? Actually they can repeat any number of times. For example, you should be able to generate ab whole square, then cb, and then cb whole square. This should be able to generate. Do you agree with me? Okay, yes or no? We should be able to generate this string. Do you agree? Okay, from this I should be able to generate this string. Please tell me, is this point clear? I should be able to generate this string ab power 2 cb then cb power 2. But actually from the option C you cannot generate. Actually what this option C will generate, this option C will generate like this, that ab power n. Okay, and then you will have it, it's like this, cb power m, cb power m, cb power m, cb power m. So are you seeing the, can you see what are the mistake in the option C? Tell me, can you see the mistake in option C? Actually in the given grammar the language is generated here. These b's they can repeat any number of times. There is nothing to do with each other. Yes or no? This b can repeat 2 times, this b can repeat 100 times. Everything is fine. But if you see in option C, we cannot generate what? From option C, we cannot generate. Tell me what we cannot generate. We cannot generate, for example, AB power 2, then CB whole square. This we cannot generate. Okay, this string cannot be generated. Understood this? Please tell me. Let me know. So I hope this point is clear. So let me explain again one last time that the given grammar, because this option C is actually the most common mistake. The given grammar will generate what? It will generate AB power n, then CB plus power n. Okay, where n is greater than equal to 1. So actually you will get AB power n, then it will be like this, that CB plus, CB plus, CB plus, these n times. Okay, these will be happen n times. So this and this, they have nothing to do with each other. So you are basically getting a b power n, c b power m1, c b power m2, c b power mn. Okay, where every mi is greater than equal to 1 and n is greater than equal to 1. Okay, but if you look at option C, what option C is giving you? What the problem with option C? You look at option C. Option C is actually giving you this type of language where you have a b power n, a b power n, and then c b power m, c b power m, c b power m, and so on, c b power m. Okay, m comma n both are greater than equal to 1. Okay, I hope you are getting the point. So this is the difference between option C and the language that is generated by the given grammar. Okay, is this clear? So very easily you can see that option C is also gone, because option C cannot generate. From option C I cannot generate AB power 2 CB power 4. For example, this string I cannot generate. Okay, but actually the given grammar gives you, from the given grammar I can generate what? I can generate this AB power 2 CB power 4. This I can generate. Okay, and what about option D? Option D is also wrong. But tell me, what is the problem with option D? Tell me. Here this is n and this is m. So actually this is the problem. Is this clear? Actually option D will generate what? From option D, actually you can generate, for example, this type of string you can generate where you have AB. If you take n equal to 1, okay, then if I put n equal to 1, just put n equal to 1 in option D. In option D, you put n equal to 1, then you will get AB. then you will get a CB, but remember M is greater than equal to 1, so you can get AB, CB, 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 CB. This type of string you can generate, but actually this string is not generated here. Okay, from this given grammar, we cannot generate this type of string like AB, then CB, CB, CB. This type of string we cannot generate. Okay, understood? So you can see that is the counterexample for option D. Okay, so option D is also wrong. Your answer will be what? Your answer will be option B. So we have seen this question and the complete analysis of this question. Did you understand? Please tell me. So this is a beautiful question, GATE 2017 question. I hope you understood.